Okay, so in the video that you guys watched the other day, the other Ed puzzle, we talked briefly about ecological pyramids. And basically in the video, it told you that an ecological pyramid is another way of representing how energy moves through an ecosystem. And that you should always have more organisms that are being eaten than are doing the eating. So for example, we should always have more plants. There should always be more plants than herbivores. And there should always be more herbivores than there are carnivores. Okay, and there should always be more secondary consumers than there are first level carnivores, than there would be top consumers. And the reason for that is that as organisms are eating, they're going to use most of the energy that they eat to keep themselves alive. So if we were to use numbers to represent this, then producers are making all of the energy. When the producers make all the energy, 100% of all the energy that's actually being made or available in the ecosystem is coming from the producers. The problem is that the producers are making energy for themselves. The plants don't care about the cows that are going to eat them. In fact, they want the cows to not be there. The plants are doing photosynthesis and making food for the plants. The plants don't care about everything else in the food chain. So when the plants are making the energy, they're going to use the energy. In fact, the plants are going to use about 90% of the energy to keep themselves alive, to keep them growing, to keep them repairing themselves. And so 90% of the energy that the plants are making, they're going to use up. And they're going to use that up and it's going to be lost as heat. So 90% of the energy is going to be lost as heat. So what's left to go on to the primary consumers? Well, the primary consumers only get about 10% of the energy that the producers made. So if a primary consumer, if a cow is going to get enough energy to eat, it's going to have to eat 10 times the producers. So for one cow, if a cow weighs 1 pound, which it doesn't, it weighs a lot more than 1 pound, but if a cow weighs 1 pound, it would have to eat 10 pounds of producers in order to keep itself alive. Does that make sense? So if a cow weighs 100 pounds, it would have to eat 10,000 pounds of producers, 10,000 pounds of grass in order to get enough energy to keep itself alive. And who is the cow eating for? Well, the cow's eating for itself. It doesn't care about the humans who are going to eat it. So 90% of the energy the cow eats, it's going to use up. And so 90% of the energy is going to be lost as heat. So how much energy is actually getting to the wolf that's eating the cow? 1%. So by the time we get to a secondary consumer, they are only getting 1% of that energy from the producers. So one secondary consumer, if one secondary consumer weighs a pound, so if we have a wolf that weighs a pound, it would have to eat 100 pounds of cow in order to get enough energy to survive. Okay? 100 pounds of cow in order for 1 pound of wolf to survive. So if we have a population of wolves, they're going to have to eat a lot of cows in order to get enough energy to survive. And those cows are going to have to eat even more producers to get enough energy to survive. So what happens as we go up the energy is not only does the amount of energy get smaller, but we have to have a smaller population size, a much smaller population size. And who is that wolf eating energy for? The wolf is eating energy for itself. So 90% of that energy is going to be lost as heat. So how much energy is actually going to make it to the top consumer, the last organism on that food chain? Let's say a vulture, which is a scavenger. 0.1%. 0.1%. So one scavenger would have to eat 1,000 pounds of wolf. So if I had one scavenger, 1 pound of scavenger, 1 pound of vulture, it would have to eat 1,000 pounds of dead wolf to get enough energy to survive. 1,000 pounds. And each of those 1,000 wolves, each of them would have to eat 100 pounds of cow. And each of those would have to eat 10 pounds of producers. So if we were to do the numbers, if we have one top consumer, if we had one top consumer, like a wolf, there would have to be 1,000 secondary consumers for it to have enough energy to eat. And there would need, for each of those 1,000s, there would need to be 10,000 primary consumers. And for each of those primary consumers to get enough energy to survive, you would have to have 100,000 pounds. So if I want to have one top consumer, I would need to have a lot of things under that food chain, a lot of them under them in the food chain, in order to keep that one organism alive. Okay, so where would the decomposers be in this food chain? Well, the decomposers are always the last step. So in this one, they would be right here at the top. And they would get 0.01% of the energy. 0.01%. That's nothing. Because decomposers get so little energy from what they eat, they have to have very small bodies. Okay, so that's why bacteria and fungi are usually on the small side, because they're getting the leftovers. They're getting whatever couldn't be used by everyone else. And so they have to live off the energy that's left over. So they need to eat a lot of dead things to get enough energy to survive. And they need to keep their bodies pretty small, otherwise they would never get enough energy to survive. Okay, so why does the box at the top get smaller? Why does every level of the pyramid have to be smaller than the level before it? So let's do some questions and see what you understand. What's happening to the population of organisms as you move up the levels of the pyramid? Well, why are there always more producers than any other organisms? Okay, there has to be more producers than anything else because they're making the energy that all the other organisms are living on. Why does the population of the top consumer need to be smaller than the rest of the organisms in the ecosystem? As you go up the food chain, there's less and less energy, which means there's less energy to spread around. So, because there's less energy, there has to be less organisms living at that level. There's always going to be much fewer predators than there will be the prey eating them because one predator has to eat a lot of prey in order to get enough energy to survive. So, what's happening to the energy as we move up the levels of the energy pyramid? Okay, as we move up the food pyramid, the energy amount is going to decrease because it's getting lost as heat. Okay, last question. Based on these diagrams, which of these ecosystems would be the most stable and why? I hope you said B, because if you said B, you're right. B would be the most stable because this ecosystem has enough energy. So there's enough energy for the herbivores because there's more producers, and there's enough energy for the first carnivores because there are more herbivores, and there's more energies for the top consumer because there's more um, things that they eat than the top consumer. Okay. A wouldn't work because all of these guys on the edge, they would die. There's not enough energy for them. They're not supported. Okay. And in C, it's all upside down. Okay. What would happen in this particular ecosystem is all of these, oops, all of these would die. And all of these would die. So the only way we could make this particular ecosystem stable is if it looked like that. But what most likely happen is these guys would eat all of these guys, and then all of these would die, and all of these would die, and then everyone would die.